All right, guys, so now we are going to look at the section 11.4, and that would be the part 2. In this section, we are going to do problem number 13. And so we have a hat containing 4 marbles. One is blue, one is red, one is yellow. I got some yellow, so we're good. And one is green, if I'm correct. Red, blue, and green, yes. All right, so we have 2 marbles are to be selected at random without replacement. So I'm going to take 2 without replacement. But because they're not telling you they are picking up the ball in the same time, that means they are picking 1 ball and then they are picking a second ball. So for the first ball, we have 4 choices. And for the second ball, because there is no replacement, there will be 3 choices. So the counting principle is telling us that we will have a number of sample points in the sample space equal to 12, which is 4 multiplied by 3. If we have to, and that will be for the question 1a, if we have to do the tree diagram, what do we have? Well, we have blue, we have the red, we have the yellow, and we have the green. And for each, the second ball, as soon as I take the first ball and my first ball is blue, then I will have for the second ball 3 choices, which will be a red, a yellow, or green. For the second one, it will be a blue, it will be a yellow, or it will be a green. For the third one, it will be a blue, it will be a green, or it will be a red. And for the fourth one, blue, red, and that's green, it will be blue, it could be red, or it could be yellow. How many points do I have in my sample space? I have 12 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C. Determine the probability of selecting exactly 1 red marble. So the probability to have 1 red marble exactly. So how many times do I have at least 1 red? I have 6 times at least 1 red out of the 12. So the probability is going to be 1/2. For D, at least 1 marble is not red. At least 1 marble is not red. So the probability that 1 marble at least is not red. And the probability is equal to 1. And that's pretty simple, because when you take the first one, if there is no red, you have at least it could be blue, yellow, or green. And so you can have the other one red, you don't care. And if the first one is red, that means there is no more red to take. So there is 12 cases out of the 12. And so you end up to have a probability equal to 1. Now for the question E, no green marbles. So if I look at E, and we are looking at E, the probability to have no green, not a green. So that is going to be, that means it could be, and I'm looking at basically at a blue red, a blue yellow, a red blue, a red yellow, a yellow blue, a yellow red, and that's it. 1, 2, 3, 4, 5, 6. 6 divided by 12, 1/2. Let's try to do problem number 16 now. On the problem number 16, Shelby Garden sells bonsai trees. Customer can choose a juniper, a maple, a fir, or a boxwood. So we have a G, we have a maple, we have fir, and we have boxwood. And we need to determine the sample space. So you can see that it's going to be pretty much the same idea than the previous one. So what do we have? We have for the first, well, we are going to have basically for the first cell, and we need to going to select it one bonsai tree. The chance are going to select one of the bonsai tree and one of the base at random. So we have 4 bases, circular, oval, or square. So I have 3 bases. So we have 3 bases, the circular, the oval, and the square. And the chain are going to select one bonsai tree and one base at random. So we have 4 choices for the bonsai, we have 3 choices for the base, and that gives us 12. If I look at the tree diagram, I'm going to have for each base, I'm going to have for each base 4 choices for my tree, F and B, and I can do that again, 1, 2, 3, 4, 1, 2, 3, and 4, G, M, F, B, G, M, F, B, which give me 12. So if I could, if I want to repeat that, it would be a CG, CF, C, M, and CB. It would be a OG, OF, OM, and OB, and SG, SF, SM, and SB. And now they're asking you to calculate the probability that we have a juniper tree. So the probability to have a juniper tree is equal to 1 out of the 4 choices I have. D, the maple tree and the square base. So the probability to have one maple tree and square base. So when I look at maple tree and square base, it's only 1 out of 12. 1 out of 12. For E, a tree other than the boxwood. A tree other than a boxwood. And there is 9, the tree other, probably that other, or not a boxwood, so not a boxwood. So it's 2 options for me, I can count. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count? Oh, I count this one, I should not count this one. And 9. So it will be 9 out of 12. But I could also, the probability to not have a boxwood will be the probability of, will be 1 minus the probability of having a boxwood. So what do we have? 1 minus, and what is the probability to have a boxwood? The probability to have a boxwood will be 1, 2, and 3. So it will be 1 minus 3 out of 12, and I found again 9 out of 12. Let me choose the green color for this one, probability to have a boxwood. Okay, let's try to do one more, and I'm going to do problem number 20 for you. So I decided to be a little bit ahead to save some time on the video. And basically you have 3 different people are to be selected at random, and each will be given 1 gift card. There is 1 card from Home Depot, Best Buy, and Red Lobster. The first person select gets to choose one of the cards. The second person select the between the two remaining cards, and the third person has no choice than to take the third card. The question number 1 was to define the sample space and the number. So basically what we have is we have, and I just represented in the same time the question B, you will forgive me for that. So that will be, if I have to do A, you are going to have, for the first person, you are going to have 3 choices. For the second person, you are going to have 2 choices. And then for the last person, you will have only 1 choices. Because every time out of the Best Buy, Red Lobster, and Home Depot, the first one will have first person will have 3 choices. And then the second person is going to have only 2 choices. And the third person will have only 1 choices. So, by example, if I decide to say the first person will choose Home Depot, so therefore on the second choice you will have only between Best Lobster and Red Lobster, and let's imagine the second person is taking Best Buy. That means the last person will have only so first person, I should write person number 1, person number 2, and person number 3. So the sample space is supposed to be 6. Now if I take a look at B, which is constructed that tree diagram, that is my tree diagram right here. Let's imagine that we have Home Depot for the first card. So now we have Best Buy and Red Lobster as a second choice for the second person. And obviously the last one right here will be ending up to have Red Lobster. This one will end up to have Best Buy. The third one will have to have Red Lobster, or right here Home Depot. This one will end up to have Home Depot, and this one will end up to have Best Buy. So on my C, what do we have? On my C, we are taking, calculating the Best Buy card is selected first. So the probability that Best Buy is selected first, well, that is 1 out of 3 choices. At the first time, I have 3 choices and only one worst one to have Best Buy. Now, on the question D, the Home Depot card is selected first, and then Red Lobster card is selected. So if I look at Home Depot first, and then Red Lobster, so the probability to have Home Depot, Red Lobster. So I can see that only 1 Home Depot Red Lobster is right here. 1 out of 6. 1 divided by the total number of income, which is 6. For E, the cards are selected in this order: Best Buy, Red Lobster, and then Home Depot. So the probability to have Best Buy, Red Lobster, Home Depot, where the only possibility Best Buy, Red Lobster, Home Depot, it's only 1 out of 6. So it's going to be 1 divided by total number of outcome, which is 6. All right, guys. So remember, there is few things to remember. The probability of an event happening at least once is equal to 1 minus the probability of an event that does not happen at all. Don't forget also that the probability of an event is equal to the number of outcomes favorable to the event divided by the total number of outcomes. And don't forget the counting principle. Thank you very much. And now I will move on to the section 11.5.